Deep inside the constellation, Serpens lies one of the most famous structures ever photographed in space. Immense columns of gas and dust rise through a glowing nebula like gigantic mountains floating in the vacuum of the galaxy. These structures are known as the Pillars of Creation. They exist inside a vast, star-forming region called the Eagle Nebula, located roughly 6,500 light-years away in the Milky Way. When the famous image of these pillars was captured by the Hubble Space Telescope in 1995, it instantly became one of the most iconic pictures in the history of astronomy. The image revealed enormous structures sculpted by radiation from newly formed stars. But photographs only show their beauty. To truly understand them, one has to imagine what it would feel like to fly directly into these colossal towers of gas and dust. Approaching the stellar nursery. From far away, the Eagle Nebula appears as a faint glowing cloud suspended among thousands of stars. The region spans dozens of light years and contains vast reservoirs of hydrogen gas, cosmic dust, and newborn stars. As a spacecraft approaches the nebula, the darkness of space slowly begins to glow. Radiation from massive young stars energizes the surrounding hydrogen gas, causing it to emit a soft reddish light. The nebula begins to resemble a luminous cosmic fog stretching across enormous distances. Within this glowing cloud, the pillars of creation rise like towering cliffs. Each pillar stretches several light-years in length. For comparison, 1 light-year equals nearly 10 trillion kilometers. These structures are so vast that our entire solar system would appear microscopic inside them. From a distance, they resemble gigantic fingers pointing toward the center of the nebula. But up close, their structure becomes far more complex. Mountains made of gas. Despite their dramatic appearance, the pillars are not solid objects. They are dense columns of cold molecular gas mixed with microscopic grains of cosmic dust. These materials are the raw ingredients from which stars are born. Compared to the surrounding nebula, the pillars are much denser. That density allows them to resist the intense radiation coming from nearby massive stars. Those stars emit enormous amounts of ultraviolet radiation, which blasts the surrounding gas away. Over time, this radiation erodes the nebula and sculpts the remaining dense regions into towering structures. The pillars of creation are essentially the last surviving pockets of dense material that have not yet been blown apart. Radiation slowly strips away their outer layers, causing streams of gas to flow outward like cosmic smoke. Flying closer to one of these pillars would reveal an environment that feels alive with motion. Inside the cosmic fog. As the spacecraft enters the outer region of a pillar, visibility would begin to drop. The dust particles mixed within the gas scatter light, creating a hazy environment similar to a thick fog illuminated by distant starlight. The surrounding glow of the nebula would fade into diffuse shadows. The gas density inside the pillar is still incredibly low compared to anything on Earth. Even the densest parts contain far fewer particles than the best vacuum chambers built by humans. Yet, on astronomical scales, this material is dense enough to form stars. Within the pillar, clumps of gas slowly collapse under their own gravity. Over thousands and millions of years, these collapsing pockets become hotter and denser. Eventually, they ignite nuclear fusion. A new star is born. The birthplaces of suns. Inside the pillars, astronomers have detected numerous dense knots of gas known as evaporating gaseous globules. These small regions are the true cradles of newborn stars. As gravity pulls material inward, the collapsing gas begins forming a rotating disk around a growing protostar. Over time, the temperature in the core rises until nuclear fusion begins. At that moment, the young star starts shining. However, The environment around these newborn stars is extremely hostile. Radiation from massive nearby stars continues blasting the pillars with powerful ultraviolet light. This radiation slowly erodes the structures, tearing them apart molecule by molecule. Ironically, the same radiation that sculpts the pillars also threatens to destroy the very regions where new stars are forming. The clock is always ticking for structures like these. Erosion by stellar radiation. The pillars are constantly under attack from intense radiation produced by massive stars in the Eagle Nebula. These stars are far more powerful than the Sun. Their ultraviolet radiation heats the surfaces of the pillars, causing gas to evaporate and stream away into space. This process gradually thins and weakens the structures. Over time, the pillars shrink. Astronomers estimate that the famous structures we see today may survive only a few 100,000 more years, which is a very short time in cosmic terms. Eventually, they will completely disappear, leaving behind only the stars that formed inside them. What appears to us as a permanent cosmic monument is actually a temporary stage in the life cycle of the galaxy. A violent history. Evidence suggests that the region may have experienced even more dramatic events. Some astronomers believe that a nearby supernova explosion may have already blasted through the Eagle Nebula thousands of years ago. If that is true, the shockwave could already be tearing apart the pillars. Because the nebula is thousands of light years away, we see it as it looked in the past. It is possible that the pillars no longer exist in their original form today. If a powerful shockwave passed through the region, it would compress the gas clouds, trigger additional star formation, and shred the remaining structures. The majestic columns captured by the Hubble Space Telescope might already be fading remnants of something even more dramatic. The cycle of the galaxy. The pillars of creation represent one moment in a much larger cosmic cycle. Gas clouds collapse and form stars. Those stars shine for millions or billions of years before eventually dying. Massive stars explode as supernovae, scattering heavy elements back into space. Those elements mix with new clouds of gas and dust, eventually forming the next generation of stars and planets. The atoms that make up Earth, oceans, and living organisms were forged in ancient stars long before the solar system formed. Structures, like the pillars of creation, are simply the visible stages of that endless process. They show the moment when raw interstellar material begins its transformation into new suns. Somewhere inside those towering clouds, future solar systems may already be forming, and in a few million years, entirely new stars will shine where these dark columns once stood.